Okay, I know that what we've been doing has been a little bit confusing. It's a lot of information to take in, so I want to kind of make you a little video to go over each of these concepts so that you have this to look at home to help you study. We know that slope is equal to change in y over the change in the x values. So if I have the slope of a line on a graph, let's say I have this graph here, and it tells me that I have a point here at, my x would be 0, my y will say is 3. Here I have a point at, we'll say this is 5, so it would be x is 5, y is 0. So in order to find the slope, I just plug those into my equation. My y minus y1. It does not matter which set I let be the x1s and x1 and y1 or x2 and y2. What matters is that we line them up. One set of ordered pairs is directly over top of the other set of ordered pairs. Okay, so I'm just going to let this be x1, y1, and let this be x2, y2. So I'm going to have 0 minus 3 over 5 minus 0. So I end up with a slope of negative 3 over 5. And that makes sense because my line is going down as it moves left to right. So I know that the slope should, in fact, be negative. So that's how I would find the slope when given 2 points. Let's say that I want to use this same information now and I want to write an equation in slope-intercept form. Okay, well, we know in order to be able to write an equation in slope-intercept form, I need 2 pieces of information. Slope-intercept form is the y equals mx plus b. M is my slope, B is where it crosses the y-axis. Well, we just discovered that our slope is negative 3/5, and we can look at the graph and see exactly where it crosses the y-axis. It crosses the y-axis at this point 0, 3. So I can write my equation y equals negative 3/5 x, that's my slope times x, plus the y-intercept. At what point does it cross the y-axis? Up here at 3. So my equation is y equals negative 3/5 x plus 3. Let's say, though, that I just gave you a slope at a point, like the negative 3/5. That's the slope. And we'll go back and say that I gave you this point down here, this, what was that? 5, 0. But I didn't give you the graph. Well, we could use a couple different things here. We could graph it and try to find the y-intercept. Or, since we have the point and the slope, we could use point-slope form, which is y minus y1, which is equal to the slope times x minus x1, where the x1 and the y1 are the ordered pair that we were given. They're the coordinates of the point we were given. And then this x and this y, they're just constants. We're not trying to plug anything in for those. And we know the slope is negative 3/5. So I have y minus 0 equals negative 3/5 times x minus 5. Okay, if I just distribute this negative 3/5, I have negative 3/5 x. Negative 3/5 times this negative 5 here gives me a positive, well, 3 times 5 is 15. 15 over 5 would just be 3, or you can think of it as the 5's canceling. They become 1, so I'm left with 3. Equals, well, y minus 0 we know is just y. Look what happened here. We used point-slope form and solved it out to get slope-intercept form, and it happened to be the exact same as what we had here. Y equals negative 3/5 x plus 3. Y equals negative 3/5 x plus 3. So that's 2 different ways of writing an equation using the same information or maybe a little bit different information. Another thing that we've been talking about is parallel lines. You know that parallel lines have equal slopes. So if I tell you that I have a line that the equation of the line is y equals 3x plus 2, And there's another line that's parallel to this line. And we don't know its equation, but we know it passes through the point 2, 3. Okay, so what I want to do is write an equation of this new line that is parallel to the graph of the equation, or the line of this equation, and passes through this point. So the only thing that I need from this is the slope, because since my lines are parallel, I know that they have equal slopes. So I know the slope of my new line is also going to be 3. So now I'm done with that. I'm just going to cross it out so I don't confuse myself. And I know that it passes through the point 2, 3. So I have a point and I have a slope. So in order to write the equation, I'm going to use point-slope form, which is y minus y1, which is equal to m times x minus x1. So plug in the information where it goes. Y minus 3 equals 3 times x minus 2. We distribute. We've got 3x minus 6 is equal to y minus 3. I want y all by itself. So to get rid of the minus 3, I add 3 to its like term on the other side. Y equals 3x minus 3. Notice the slopes are the same because they're parallel, but they have different y-intercepts, so they're not overlapping each other. So the equation of the line that's parallel to this line is y equals 3x minus 3. If I told you that they were perpendicular, let's say I have y equals 3x plus 2, I want a line that's perpendicular to it and passes through the point, I don't know, I'm just making these up off the top of my head, so negative 1, 2, we'll say. Okay, well, what do we know about perpendicular lines? Their slopes are opposite reciprocals. So the slope of this line is 3, or 3 over 1. So its opposite is going to be a negative, and a reciprocal just means I flip the fraction. So I have negative 1 over 3. Okay, so here's the slope of my new line. I'm done with all this. I'm going to cross it out so it doesn't confuse me. And I know that it passes through the point negative 1, 2. Okay, so let's plug it in. Y minus 2 equals negative 1/3 times x minus negative 1. What happens when I have minus a negative? It becomes plus a positive. So I have y minus 2 equals a negative 1/3 x. I'm just going to distribute minus 1/3. Negative 1/3 times a positive 1 is a negative 1/3. Then I add 2 to both sides. So y equals negative 1/3 x. A negative 1/3 plus 2 is going to give me a positive 1 2/3, which is kind of messy looking, so let's convert it to an improper fraction. 3 times 1 is 3, 3 plus 2 is 5. So my answer is y equals negative 1/3 x plus 5/3.